Hello good people, Mr. Tankaulona. I'm back again with another video. So today sobasenza a quadratic sequence. We're dealing with the quadratic sequence. As you quadratic sequence. It has to deal with a parabola, but in this case it's a pattern, ever. Okay, so please don't forget on our channel Lana at Mr. Tankau, don't forget to subscribe. And then you must hit that like button, ever. And tell us, ne? Okay, so before we do our questions, we'll just do a brief some notes about the quadratic sequence. How will you see that this is a quadratic pattern? Ne? Okay, so now let's check. So I wrote some notes. A quadratic pattern. First thing with the quadratic pattern, the first difference of a quadratic pattern is not the same. First difference here, it's not the same, or it's not constant, ne? But the first difference of a quadratic pattern forms another pattern, which is called what? An arithmetic. And then another word for your arithmetic pattern, we were told in grade 10 that we were taught in grade 10 about a linear pattern. So a linear pattern is the same as what? Our arithmetic pattern. Okay, so now when it comes to quadratic sequence, the first difference is not what? It's not the same, or we can say it's not common, it's not constant. Ne? So now how do you see that a pattern is quadratic? By its second what? Difference. Okay, so our bullet number 2, it says what? The second difference of a quadratic sequence is constant. So is second I'm erasing. So our second difference in journey is constant. Therefore we conclude that it's what? The quadratic pattern if the second difference is constant. So I said something. I said our quadratic sequence can be compared to any parabola. Remember, smiling or sad. Okay, so now let's check. We are given a pattern here, a sequence. So now let's check this pattern. Is it arithmetic, is it quadratic, or is it geometric? Remember we said, how do you find the difference? The term on your right minus the term on your left. We don't say left minus right, otherwise you'll be wrong, ne? So now let's check. What is 8 minus 3? It's 5. And then what is 17 minus 8? 17 minus 8 is 9. And then 30 minus 17, it must be 13. 30 minus 17 is 13. And then 47 minus 30 must be 17. Okay, so now can you see our first difference, Lana? Let me do this thing. Our first difference is not the same, so we can't say this pattern that was given is arithmetic, because the first difference is what? It's not the same. So now let's check our second difference. So this is our what? Our first difference. Okay, so now let's check our second difference. Our second difference, 9 minus 5 is 4. 13 minus 9 is 4. 17 minus 13 is 4. Okay, that's nice. So now what do you notice from a second difference here too? Our second difference is what? It's the same. We're having a constant Villa panel of what? Of 4. So now if a pattern is having a constant a second difference which is constant, therefore we say that pattern is what? Is quadratic. Good? Okay. So now if maybe they ask you to determine the general term of this pattern, of this one, 5, 9, 13, 27. So we'll use this formula. T is equals to A into n minus 1 into D. Why? Because we said the first difference of a quadratic pattern is what? It's arithmetic. Good? Okay, so now let's check how do we determine the general term of a quadratic pattern. So you have to remember your standard form. Remember your standard form? Ax squared plus bx plus c. So now we'll replace our x with n. Okay, so now let's check the general term of a quadratic sequence. It says Tn is equals to an squared plus bn plus c. So now you'll ask yourself, how do I get the value of a, the value of b, and the value of c? Okay, let me pause the video and do something. Okay, so the question may be, how will you get the value of a, the value of b, and the value of c? So the time when they were introducing a quadratic pattern to us in grade 11, first thing what they did, they substituted 1 where you see n. So we managed to get our term 1 as a plus b plus c. Okay, and then term number 2 where you see n substitute 2, you'll get 4a plus 2b plus c. And then term number 3, you'll get 9a plus 3b plus c. Term number 4 and term number 5. Okay, so now let's do something again. Okay, so now we have term 1, term 2, term 3, term 4, then term 5. So now let's find the difference. The difference between term 2 and term 1. 4a minus a, it will give us what? 3a. 2b plus minus b will give us what? b. C minus c, c will disappear. Term 3 minus term 2, and 9a minus 4a, which is 5a. 3b minus 2b, which is b. C minus c, c will cancel. Okay, then term 4 minus term 3, 16a minus 9a, which is it 7? 7a. 4b minus 3b, which is b. C minus c, 0. Term 5 minus term 4, 25 minus 16, which is 9, 9a. 9a. And then 5b minus 4b, which is b. Then c will cancel c. And now let's check. Can you see our first difference is not the same? And now let's check our second difference. 5a minus 3a, which is 2a. And then b minus b, 0. 7a minus, which is 2a, and then this one 2a. Can you see your b will cancel each other? Then now they told us something in grade 11 that we use a bottom up. They said the important things Lana is your 2a, your 2a, your 3a plus b, your a plus b plus c. These three things are very important when you're dealing with what? A quadratic pattern. Very, very important. Okay, so now how do you get the value of a, the value of b, and the value of c? So we said what? Bottom up. If you're doing accounting, we'll say FIFO, first in, first out. So it's bottom up, ne? So we start with a, going up. So we'll get A, B, then C. Okay, so now let's check bullet number 1. This 2A, you equate to your second difference and solve for A. Bullet number 2, your 3A plus B, you equate to the first term in the first difference. And then first term in the first difference. Okay, and then the last one, your A plus B plus C equated to first term in the quadratic sequence. And then so now let's go back to our sequence that was given in this case. Let me take this sequence. Okay, for example, if maybe we are being asked to find the general term of this pattern in the form of Tn is equal to an squared plus bn plus c. So we get our second difference, then we say 2a is equals to the second difference. Your 3a plus b is equals to the first term in the first difference, which is 5. Then our a plus b plus c is equals to the first term of the quadratic sequence. Okay, so now let's start. So our 2a will be equals to 4, then we divide by 2, then our a is positive. Okay, our 3a plus b is equals to 5. We already know the value of a, which is 2, plus b is equals to 5. 2 times 3 is 6, therefore our b will be equals to -1. Then a plus b plus c is equals to 3. Then we'll have what? Our a is 2 minus 1 plus c, which is equals to 3. Therefore our c is equals to, what is 3 minus 1, which is 2. Therefore our general term, where we see a, we put what? 2 n squared. Our b is -n, then our c is 2. Then we're done. So that's how we determine what the general term of a quadratic pattern. Then now we said something, folks, just to explain it. We said something. We said what is it, guys? We said what? We said a quadratic pattern can be compared to what? A parabola. Remember our parabola? Our parabola says what? Y is equals to ax squared plus bx plus c. Ne? Or sometimes they use this one. Y is equals to a into x plus p squared plus q. What do you know about this q? Q is the y value of what? The turning point. It can be maximum or can be minimum. Okay, so now q, in order for it to be maximum or minimum, it depends on what? Depends on a, whether a is positive or negative, right? Okay, let me write Lana parabola. Okay, so now let's check in this pattern that you're dealing with, how is the value of a? The value of a is what? Is positive. So if the value of a is positive, are we expecting to have a maximum or minimum? If you still remember, on our parabola, we're told that when a is greater than 0, our graph is smiling. Therefore, if it's smiling, we'll have what? Minimum. And then if it's set less than 0, our graph will be set. Then we'll have what? Maximum. And some people, they even use, okay, not some people, value, we always use this formula over 2a. And then But when it comes to number patterns now, we won't be saying x, we'll be saying what? N, which means to n law will be giving us the position of what? Of the maximum or the minimum. Okay,